explain how to do assignment number 7, circuit calculations. So there is like some problems that you're going to do, and there's also a bit of reading and like resources that you can use to help you solve the problems. So here's the resource that you can use to help solve, and the key things here would be the difference between a series circuit and a parallel circuit. So, key idea for the series circuit, the current through each resistor is the same and it is equal to the total current throughout the circuit. And then the sum of the voltages across each resistor is equal to the total of the voltage of the battery. And last thing would be, in order to calculate the total resistance with all the resistors together, you simply add them, like resistor 1 plus resistor 2 plus resistor 3, and then the N here, that's just indicating it can go up to however many resistors there are. For the parallel circuit, the voltage is the same across each resistor, and it's equal to the total voltage of the battery. The sum of the current through each resistor is equal to the total current of the circuit, and the total resistance is calculated by 1 over R total is equal to 1 over R1 plus 1 over R2 plus however many resistors there are. Let's see. I don't know why, there's like a different version that's on Google Classroom. I'm not sure where it went. Oh well, that's okay. So your worksheet will look slightly different because it's numbered, and then it also has some extra instructions here, which just tells you to draw the circuit. But it's alright. Alright, so I'm going to go through how to do one of the series problems and then one of the parallel problems. So let's look at this first one. So we have a series circuit with 2 resistors, and we're given some information. We're told that the voltage is 3600 and R1 is 500 ohms, R2 is 700 ohms. So I'm just going to label my diagram. And then, let's see. Alright, and now the first thing that I'm going to do, and I guess you can't follow this exact pattern of solving the problem because you get different information for each one, but for this one, I'm going to start off by calculating the total resistance because I have the values for all of the resistors that are in the circuit, so I'm just going to calculate that first. So R total is equal to, and let me just write out the equation, so R1 plus R2. So R total is equal to 500 plus 700. And so 1200 ohms is our total resistance. And the next thing I can do, well, since I have the voltage and I have the resistance, the total voltage and the total resistance, I'm going to calculate the total current. So the equation that I'm going to use, V equals current times resistance. And since I'm solving for current, I'm just going to rearrange this equation to have it set to isolate current. So I'm going to divide by resistance on both sides. I end up with current is equal to voltage divided by resistance. So just to save room, I'm going to move that over there. Oh, whoops. Okay. So my voltage is 3600. And my resistance, the total is 1200 ohms. So my total current is 3, and the unit for current is amps. So now that I have that, this is where if you aren't paying attention to the actual conceptual aspect of this assignment, or about circuits in general, then you're going to run into trouble. And so the thing that you have to remember is that the current is constant in a series circuit. So it's going to be 3 amps here and 3 amps there. Now that you know that, it's going to be easy to calculate the remaining voltages and then of course all the power. So let's see, V equals IR. So I'm going to solve for R1 right now. I'm just going to leave units out until the end, just to try to keep it simple. No. All right, now I'll do the next one. And there's 2 ways you could do this. One would be conceptually. So for series circuits, the voltage across resistor 1 plus the voltage across resistor 2 is equal to the total voltage. So you could take 3600 minus 1500 and get this. I'm just going to use Ohm's law. So once again, V equals IR. The current is 3 amps. Oh yeah, units. Oh. Times 700 ohms. And let's just verify that those 2 voltages add up to 3600. So 1500 plus 2100. Ta-da! That was supposed to be, should have done a check mark. So there, that's a way to kind of check your work. All right, to get the power, and I'm just gonna erase that. Okay, to get the power equals current times voltage. So you're gonna be multiplying these 2 columns, or the cells. You'll be multiplying each item in across the row with these 2 columns. So for the first one, And our unit for power is watts. And I think you guys can do the rest. So that's how you solve for series circuits. Now, I'll go down to a parallel circuit. And I'll do the one at the bottom. So, first thing I'm going to do is fill out my chart. So we're given the total voltage and then each value for these resistors. So I'm just going to number the resistors will just be like R1, R2, R3, R4 from left to right. So the first one, R1 is 2 ohms, R2 is 3 ohms, R4 2 ohms, R5 another 2 ohm. And then we also have the voltage, the total voltage, which is 18. And my next step from here is I'm going to calculate the total resistance. So this is the one where it's kind of a weird equation. So 1 over R total is equal to 1 over R1 plus 1 over R2. And I'll fill that out now. And you could keep everything in fractions if you hate yourself and want to make this longer than it needs to be. But I am just going to put all these in decimal form. Makes it a lot easier. Oops. 0.5 plus 0.5. Alright, so now I'm going to add that together. So 0.5 plus 0.33 times, there's a million threes. I'm just going to do 0.33. And then plus 0.5 again, and then plus another 0.5. So I get 1 over RT is equal to 1.83. And that is not your answer. So this, like when you get here, don't celebrate yet because you're not done. We're solving for RT, not 1 over RT. So I'm just going to take the reciprocal of both of them. So what that looks like would be the reason I can do that, according to the rules of algebra, so 1 over x equals 3. Let's say this is our problem. So this is the same setup as this. If I was solving for x, I could multiply by x on both sides of my equation. I get 1 equals 3x. Not done yet. Last thing I need to do is divide by 3. And I get x is equal to 1/3. So this is the idea of what I just did. And yeah, I guess that's it. So now I don't want you to write this as your answer. You actually plug this into your calculator. So in my calculator, I'm typing 1 divided by 1.83. And I get 0.546. And I'm going to round to 0.55. And you'll notice that the more resistors that you have in parallel, the more, or the lower your resistance is going to be. So as you add another resistor in parallel, your total resistance goes down. So it's kind of like you're adding another lane for current to travel through. All right, so now here we go. So the next thing I'll do is I'll solve for the current. I'm choosing that because I have the voltage and I have the resistance, so I'm going to go for the current. Using the equation from before, oh, did I erase it? Oh no. So current is equal to voltage divided by resistance. So 32.7. And our unit is amps. Now, in our previous series problem, we were able to say, oh, the current is constant all the way for the whole circuit. And that was really helpful. But we can't do that for this circuit. But what we can do is that same kind of thing, but for voltage. So this one gets 18 volts, R2 gets 18 volts, R3 gets 18 volts, and so does R4. Knowing that, you can easily calculate the current by just taking, by using this equation. And then, once you have that, you can calculate the power using P equals IV. And that's it for this assignment. I guess I'll point out this circuit kind of looks funny. Another way that this could be drawn would be like that. There's lots of different styles for drawing circuit diagrams. And yeah, so don't let this trip you up. It's just a parallel circuit. And then, oh yeah, I forgot to do this one. I'll draw out this circuit too. So, given the following information, complete the table for 4 resistors in series. And then over on the right hand side it says draw the circuit. So, the only thing we have in this is a battery, so we have voltage and then we have resistors. So since we have 4 resistors, that means I'm going to draw 4. So start off with my battery, and for the battery you draw like a long line and then a short line. Technically that's a battery, or that's a cell, so if you wanted it to be like a true battery, a battery is like a combination of cells. So this, I guess, would be, I don't know if anyone would say it was more accurate, but just so you know. Okay, I'm like drawing at a really weird angle, but this is a really ugly version, but that's what it would look like. So we have R1, R2, R3, and R4. Alright, I hope this was helpful.